Okay, looks like we're going to work here now. Okay, so here's our first homework problem. You guys tell me, how do I find the radius of the circle for the arc? Okay. I split that into 12 and 12. That's just half of the 24. Then this is 8. If I call this piece x, I know that 12 times 12 equals 8x. So 12 times 12 divided by 8 is correct. What does that give us? 18 equals x, is that right? So then the diameter is 26, and the radius is 13 millimeters. Questions so far? So that's the radius, that's the easy part. To find the volume of this, we're going to find the area of the base. The base is this piece right here. Well, that piece is nothing more than a rectangle with this portion of a circle here, this segment of a circle cut out of it. So that rectangle is 30 millimeters here by 96 millimeters there, which is what? 2880, thank you, millimeters squared. So from that, we have to subtract that segment. So we've got to find the area of that segment. So we're back up here to this triangle here, or this circle here. We're forming that triangle. So we're going to take a look closer at this triangle here. So let's pull that out. So within this triangle here, we have 12 here. Then we have 13 here. I'm going to need to know this side, and I'm going to need to know this angle. How would I find this side? There you go. A squared plus b squared equals c squared. That side comes out to be the square root of 13 squared minus 12 squared, which ends up being 5. So that side's 5 units. To find this angle, I have the opposite side in the hypotenuse, which is tangent. Or not tangent, sine. Thank you. We got tangent on the brain today. So we plug in what we know. Sine of our angle is 12 over 13. So we will do an inverse sine. So second sine 12 divided by 13. 67.38 degrees. Now we need to double that. We gotta get the whole angle. So it is 134.76. So this angle right here is 134.76 degrees. So we need to find the area of that sector right here, which is going to be found from finding the area of the whole circle. The area of the whole circle is pi times 13 squared. 3.14 times 13 squared. 530.66. So then the area of that sector is is the area of the circle, the 530.66, times the 134.76 over 360. $198.64 is the area of that sector. From that, we're going to subtract the area of the triangle. The triangle, we found this height here to be 5 from here, and the width here is 24. So the area of that triangle is 24 times 5 over 2, which is 60 millimeters squared. So that subtracts, goes 138.64 millimeters squared is the area of that segment. So that has to be subtracted. What we found there again was this piece here that's missing. So we subtract that from the area of that whole rectangle. It's going to give us 2,661.36 millimeters squared. Is that correct? Say no. It's not. $2,741.36. Sound better? So that's the area of the base, the area of that highlighted spot. So we need volume yet. Volume will be the area of that base times, what are we going to multiply it from out of here? 72, yes. That's what takes that base to the opposite side, is the 72. Times 72 millimeters. 2741.36 times 72. So 197,377.92. Millimeters cubed. Change it to centimeters cubed. 197.38 centimeters cubed if you wanted to make a change. Either one of those answers would be acceptable. Any questions? How many of you came up with that for number 1? How many of you came up with an answer for number 1?
I did half of it just to find what I was doing.
Okay. Number 2, anybody want to throw out what they have for an answer? Nobody wants to be brave? Number 2, XN for the area. What's that? Yep. 189 point anything? 034. 9908. Point 668 millimeters squared. Anybody else getting close to that? LSAP. I'm going to leave the millimeters off of the measurements just for speed here. Okay. So I'm going to start right here with this triangle. No, this is the homework.
This one is different.
Oh, you got the wrong copy. Hang on to that, but that'll come in useful in a few minutes. Here, I'll give you this one though, so you've got the right copy. Okay. So we're looking at that triangle first. In that triangle, this side is 20, just half of the 40. This side is 32, the radius of that circle. We can find this distance here. That's going to be the square root of 32 squared minus 20 squared. $24.980. And we're going to find this angle here. That's just going to be the inverse tangent, or sorry, inverse sine of 20 over 32. $38.68 degrees. So we're going to double that because what we really want, 77.36, is this angle here. 77.36. And really what we want is this angle here. So we're going to subtract that from 360. 282.64 degrees. Now we're going to do the same thing over on the other side here. We're going to look at that triangle. Again, we're going to cut it in half. We're going to take this right triangle out of there. This here is still 20, half of the 40. This here is still 44, the radius of that circle, half of the 88. This side up here is just going to be the square root of 44 squared minus 20 squared. $39.192. Then this angle here is going to be the inverse sine of 20 over 44. $27.04 degrees. Again, we're going to double it because we want this angle. Gives us 54.07. Then we're going to subtract from 360 because again, we really want that angle. $305.93. Okay. So now we have the length x across there. From here to here is just the radius of that circle, which is going to be 32. From here to here is that piece there, 24.980. From here to here is this piece, the 39.192. And from here to here is 44, just the radius of that circle. Gives me 184.172 is x. And for area, Well, our area, we just have 5 pieces here. Piece 1, we have that rectangle in the middle there that's 40 by 44. 1760. Piece 2, we got that triangle there that is 40 by 24.980, so we're going to divide that by 2. $499.6. We got this triangle here. It's 40 by 39.192 divided by 2. $783.84. And then we have the sectors of the circles. So I'm going to call this one number 4. I'm going to need a little bit more room for that. So it's the area of the circle, pi, times the radius of 32 squared, times that angle of 282.64 over 360. Giving us 25, 24, 41. And then piece 5 here, same thing. That's going to be pi times 44 squared to give me the area of the whole circle. Times 305.93 over 360. So 5166.00. We would add those up to get the area. I'm not going to do it right now. I'm just going to assume you guys can add those up. But that's our area. Any questions on that one? So we've done that example or similar examples enough times, we should be getting relatively good at it. Now for the last one on the worksheet, I'm just going to get a light touch on it, then we're going to get the quiz out to you. So remember, these are tangents and this is a right angle. And for angle A, looking for the length of x here. This is 64 millimeters down here. 36 here. The diameter of this circle is 68. Now yesterday I gave you an example where the diameter of the circle, when we cut it in half to get a radius, it equaled this. So that when I put that radius in here that made the right angle down to my tangent, it formed a rectangle. On this homework example, however, that's 34 and this is 36. This does not form a rectangle. Which is going to complicate things a little bit for us. What's that?
That's what you were saying yesterday.
Yeah. Yeah, if it forms a rectangle, it makes the problem a lot simpler. But if I cut this across here, it actually comes in slightly below that. There's going to be 2 millimeters left over there. Which is fine. We can deal with that 2 millimeters. So what I'm going to do is I'm going to actually look at that piece right there in a little bit more detail. That's a right angle. This is 2 millimeters. This is 64 millimeters. I can cut this across here. That's a right angle because it's a horizontal hitting a vertical. I can find this side over here. A squared plus b squared equals c squared, right? So that'll be the square root of 2 squared plus 64 squared. 64.03. This angle here, that's going to be the inverse tangent of 2 over 64. 1.79 degrees. That makes this angle up here, by the way, 88.21 degrees. Just using the triangle has to add up to 180. I've got 90, 1.79, that has to be 88.21. So now I have the right angle here. I have the 64.03, and I do have, that's a radius of the circle, 34 millimeters. So I can find, this is my distance x over here. I'm going to find that by doing a squared plus b squared equals c squared. X is one of the legs, so it's going to be the square root of 64.03 squared minus 34 squared. Give us 54.257 milliliters. And then, doesn't matter which angle I find, I guess. Let's find this angle here. I'll find that angle is going to be the inverse cosine, because this is the adjacent leg, of 34 divided by 64.03. 57.93 degrees. Makes this angle here 32.07 degrees. Now I have angle A is just these two angles added together. So it's going to be 120.28 degrees. And I can find areas because I have a rectangle here. I have a right triangle here and another right triangle there. That makes this space. And I know these two angles I can add up. And this is 90 degrees here. So I take those angles and subtract from 360 to get the angle of that sector. Any questions? Are we ready for the quiz? Maybe. You do get to take this one home for the weekend and bring it back on Monday, just so you know. So if you're sure of your work, you don't have to get a fresh copy, so you can go through it again. Go through it again. It's just easy. This is a 20-point quiz, and this is going to wrap up our complex trigonometry apps. So next week we start compound angles.